Welcome students, welcome to lecture number 32 where we will be continuing with module number 4 under subject financial management. So module number 4, as you already know, is investment decisions, where we have seen what is capital budgeting. We have seen different investment evaluation techniques. We are just remaining with internal rate of return, modified internal rate of return, and case study on replacement of capital project. So today we will be covering the remaining part. So today we will be seeing internal rate of return, modified internal rate of return, and case study on replacement of capital project. So again, I'm revising the same thing. Capital budgeting techniques is divided into two types: traditional technique and modern technique. So in traditional technique, we have seen how to calculate payback period, accounting rate of return, and in case of modern method we have seen net present value and profitability index. So we will be seeing internal rate of return and modified internal rate of return, which is one of the modern techniques to calculate or to know whether an investment has to be made or no. So first let us understand internal rate of return. Students, remember, internal rate of return is a modern technique for investment evaluation. So whenever suppose you have to make an investment, okay, this internal rate of return will help you to make a decision whether you have to go in for that particular investment or no. So let us read the meaning. This method is also called as yield on investment or rate of return method. So as the name goes, internal rate of return means whatever investment you're making, okay, what is the return you're going to get on the investment. Okay, so this method is going to tell you the rate of return which you will be getting on a particular investment that you're going to make. IRR, that is the short form of internal rate of return, is the rate of return that a project earns when NPV equals to 0. So, can anyone tell me when NPV will be equal to 0? See, we students, we know the formula to calculate NPV is PV of cash inflows minus PV of cash outflow. Now, can anyone tell me when NPV will be equal to 0? When will you get your answer as 0? When will your NPV will be equal to 0? Yes, students?
Both cash inflow
Yes?
and cash out are
Exactly. So the student has rightly said that when the PV of cash inflows and PV of cash outflow will be same. Now same means equal. So when both are will be equal, okay, at what rate of discount or what rate of return they both are getting equal. See students, we know in order to find PV of cash inflows, we have to use a rate, correct? Then we discount it and then we find out the PV. So at what rate, okay, the PV of cash inflows is equal to the PV of cash outflows, that rate is called the internal rate of return. So IRR is that rate of return that a project earns when NPV equal to 0, means the rate of return at which you are getting NPV as 0, that rate is your internal rate of return. So third point, it is a discount rate that equates, as that student rightly said, that equals cumulative PV of net cash inflows with aggregate PV of cash outflows of a project. So in short, this sentence means that the rate at which your PV of cash inflows is equal to your PV of cash outflow, it is going to be that IRR. So that rate is nothing but the internal rate of return. Okay, students, now before we see how the decision rule has to be made, logically I want to understand from you all. Suppose if your cost is high and the return is low, will you accept that proposal? If the cost is high and the return that you're getting on the investment is low, will you accept that proposal?
No, ma'am.
Similarly, if your cost is less and your return is high, will you accept that proposal?
Yes, ma'am.
Okay, so just see the decision rule. So internal rate of return is nothing but the rate of return that you're earning on a particular investment that you will be getting from a particular investment, but it is not in the form of inflows, the rate of return it is. Okay, and K stands for cost. We have already seen, like in our third module, we have seen that cost is denoted by the letter K. So if your rate of return is greater than your cost, so if your return is greater than your cost, as you already rightly have said, you have to accept the proposal. We are accepting the proposal in the decision rule. When the return is less than the cost, reject the proposal. And when the return is equal to cost, indifference means it is left to you all whether you accept, whether you reject, because the cost and the return is same. So it depends. It is indifferent. Okay, so internal rate of return, again I'm repeating, it is the rate that of return that a business earns on the investment that is making, number one. It is going to be that rate where your cash inflows will be equal to your cash outflows. That means it is the rate where NPV will be equal to 0. And decision rule in case of internal rate of return will always be compared with the cost. If your return is higher than cost, accept it; lower than cost, reject it; equal to cost, indifferent. So is internal rate of return concept clear to everyone? Yes, students? Yes?
Yes,
Yes,
ma'am.
ma'am.
Okay, next. Now, how to calculate IRR? Now, practically, when a problem is given, how will you actually calculate IRR? So, first of all, when a problem is given to you, you'll have to analyze whether the cash flows are equal. See, obviously, when you're making an investment, annually you'll be getting some cash flows, cash inflows. That means some amount of returns. So when the annual cash inflows are equal, that is every year you're getting same amount of cash inflows, then what step you have to use is step number 1, find the present value factor. Students, before we go into this, I just want to tell you all that up to now, whatever you'll have studied, you'll have studied that you use the annuity table when you have N and R, when you know the number of years and when you know the rate of return, correct? But now you have to calculate rate of return. You have to calculate this rate of return. So I'll just show you all. See, students, whenever a particular table is given, what do? You have the rate of return, okay, and you have the number of years. But now this method is to find out the rate of return. So what you have to do is you have to find out number of years will be given in the problem, okay. Corresponding to that, you have to see the PV factor. So now in IRR technique, you have to find out the PV factor. This factor you have to calculate, and corresponding to this factor, what is the rate of return? That will be the rate of return. So for example, if a project is having a life of 5 years and the PV factor you found out is 0.7130. So corresponding to this factor for 5 years, what is the rate of return? 7%. So your IRR will be 7%. So now we have to find out, how are we going to find out this PV factor? Let us see. So students, your first step will be find the present value factor. Now, did you all understand why first you have to find out present value factor? Because we have to calculate a rate of return. Till now, we were having the rate of return, we were having the number of years, and then we were calculating the present value factor. But here, the number of years is given. Okay, rate of return is something that we have to find out. So to find out the rate of return, we should know the present value factor. So for that, the first step will be find the present value factor. How are you going to calculate this factor? How will you get this factor? There is a formula, that is initial investment divided by average annual cash inflows. So what you have to do is, students, take the initial investment. Initial investment is nothing but it is going to be your cash outflow divided by average annual cash inflows. See, the cash inflows are equal in all the years. Okay, so you're going to divide it by the cash inflows. You will get the PV factor. Now, this PV factor, what you all will be getting, is this PV factor. This is called PV factor, right? So you will be getting one PV factor. Okay, the number of years will be given in the problem corresponding to the number of years and the PV factor. What is the rate? That will be the internal rate of return. So just a second. Okay, once you find out what is the present value factor, check the annuity table by finding the rate corresponding to the PV factor and number of years. Okay, so students, remember that in case of IRR, you have to go reverse. A little reverse means here R is something that you have to find out using the annuity table. Till now, we used to use these FM tables when we knew what is R, what is N. But now you will have to find out R in the FM tables, okay, by using the present value factor. Now, suppose students, again going back to okay, now suppose if the answer you're getting it as 0.6499. Okay, that is how did you get this answer? For example, you have done your average this initial investment divided by the annual cash inflows. You got it as suppose 0.6499 and for 5 years. So what is the IRR going to be? You have to see what is the rate of return corresponding to this factor for 5 years. So the rate of return is 9%. So IRR will be 9%. Is this clear, students? Up to here, is this clear? Yes? Yes?
Yes, ma'am.
Okay. Suppose if this answer, what you're getting, this answer, how did you get this PV factor? How did you calculate PV factor? Your initial investment divided by average annual cash inflows. Suppose you are not getting this exact answer. So suppose if this number is not absolute. Suppose if you're getting 0.6499, okay, this is an absolute number which you can plot it on this particular table. But suppose if you're not getting an absolute answer, suppose you did not get exactly 0.6499 or exactly whatever numbers are mentioned in this table, you're not getting that absolute exact number. Then what you will do is you have to use your formula. Okay. Now, check the annuity table by finding the rate corresponding to the PV factor and number of years. If the PV factor is not an absolute number, then IRR would be between two factors and the nearest factor is taken as IRR. See, suppose if you're not getting an exact, you're not getting an exact amount of PV factor, which you can plot it in the FM table. So suppose for 5 years you're getting something. Suppose if you're getting this is 0.6806 and this is 0.6499, and suppose the PV factor what you're getting is 0.67. Here it is 68 and it is 64. Now you're getting is 67. The answer you're getting, suppose that is initial investment divided by average annual cash inflows. If your answer you're getting it as 0.67, okay, then you know that 67 is lying somewhere between 8% and 9%. Obviously, for 5 years, for number of years, you have to see corresponding to that particular row only, depending on what number of years is given in the problem. So you know that 0.67 is lying between 8% and 9% somewhere, correct? So they are telling here if PV factor is not an absolute number, then IRR would be between two factors. Between two factors, and the nearest factor is taken as IRR. So between 8% and 9%, somewhere the IRR is lying in between. You have to take that factor. Now, how to calculate that in between is using this particular formula. So IRR is equals to X plus PX minus I divided by PX minus PY in the bracket Y minus X. Now X is your lower discount rate. So just now what I showed you, suppose 8% and 9%, your PV factor is lying between those two factors. So your lower discount rate will be 8%. plus px. So px is PV of cash inflows at x. So how you calculate present value of cash inflows? You use a rate. Okay, you use those factors, multiply the values with that factor, and you will get present value of cash inflows at x. So you have to calculate present value of cash inflows at 8%, minus I is your initial investment, the whole divided by px minus py. So that is present value of cash inflows at x. That is all the inflows you have to bring down to the present value at 8%, minus present value of cash inflows at y. So y is nothing but the higher discount rate, that is 9%. So all the present value of cash inflows, you have to discount it and bring it down at 9%. In the bracket y minus x, that is higher discount rate minus lower discount rate, that is 9% minus 8%. That is an example that I have shown you. So in this way, you calculate IRR when the annual cash inflows are equal. So again, I'm repeating, students. First of all, if a problem on IRR is given, you have to see whether the cash inflows that you're getting every year is equal or unequal. Suppose if it is equal, then your first step will be to calculate the present value factor, which is nothing but initial investment divided by average annual cash inflows. Whatever factor answer you get, you have to check it in the FM table. Okay, that where is this, what is the value or what is the rate corresponding to this factor for the number of years which is already given in the problem. Suppose if this PV factor is not absolute. By not absolute means if I say that exactly that value is not available in the table, then you know the IRR is lying between the two factors. So in that case, you're going to use this formula. So formula, we know X is nothing but the lower discount rate. PX is the present value of cash inflows at X, minus I is initial investment divided by PX minus PY, the whole multiply it with Y minus X. So this is how you're going to calculate IRR when the annual cash inflows are equal. Is this clear to everyone? Yes? Yes, students?
Yes, ma'am.
Okay, just to see whether you all have been cleared with it. Now you all have to tell me the discount rate. Sorry, you all have to tell me what is going to be the rate of return. Suppose, students, N is 10 years. Okay, if N is 10 years and the PV factor, what I've calculated is 0.4632. Suppose if N is 10 years and the PV factor answer that I have got is 0.4632. Can you all tell me what is going to be the IRR?
8%.
Yes?
8%, ma'am.
0.4632. What is going to be the IRR? Yes?
8%, ma'am.
Very good. So how you all have found out? 10 was already given in the problem. 0.4632 is the PV factor that you all have to calculate using annual investment divided by average annual cash inflows. You got 8%. Very good, students. Now suppose if the PV factor I am getting is 0.3625, then what I have to do? For 10 years, if the PV factor I'm getting as 0.3625, then what I need to do? Zero point 3625. So obviously we know that the factor is lying between two digits, two factors. So can you all tell me which are the two rates, lower discount rate and higher discount rate? For 10 years, if the PV factor I'm getting as 0.3625. So can you all tell me between what it is lying?
0.3624.
See, I'll highlight this so that it is visible to you all. If for 10 years, the PV factor I'm getting as 0.3625. 0.3625. So between which two factors is it lying? Yes, students?
Ma'am, between 10% and
Yes.
7%.
11%, and between somewhere it is lying, no, because it is not an absolute number. You cannot plot whatever number I've told you, 0.3625. You cannot plot it in the FM tables. So you have to find it between some two rates. Which are the two rates in between which it is falling?
10% and 11%.
Very good. 10% and 11%. 0.3625 is somewhere between these two numbers. So you know it is 10% and 11%. So your lower discount rate will be 10%, higher discount rate will be 11%. Use the formula that is there and get the exact IRR. So your IRR will be something like, it will be 10 point something, 10.8% or 10.7%, because it is lying between two numbers. So use this formula when the PV factor is not absolute and get your IRR. So now this is when annual cash inflows are equal. I hope everyone has understood this. Now next, how to calculate IRR when the cash inflows are unequal. Means suppose now every year whatever inflows one is getting from the investment, suppose that the value of that is not same every year. This year they have got suppose 2 lakhs, next year they're getting 1 lakh, after that they're getting 1 lakh 50, which is not equal. So then how the IRR needs to be calculated? IRR has to be calculated using trial and error method. Now the word itself says trial and error method is to use a judgment, just to try, and if it doesn't, if that rate is not the rate correct rate, then you have to change the rate. So trial and error method is a judgment method. So the first is determine the first trial rate. Trial means you're just going to try a particular rate. Now which rate should I try first? Suppose if I have a particular investment, can I just randomly pick any rate as IRR? Can I just pick 10%? No. How to get that first trial rate? Okay, I have to have some base, no, to pick one rate as, trial. Even to try, you have to have some judgment. So how to determine the first trial rate? So first trial rate by these steps. Okay, let us see the steps. PV factor. Now, what is how to calculate PV factor? As you already know, it is initial investment divided by average annual cash inflows. This we have already seen in our earlier slide. But these cash inflows are unequal. So if they are unequal, how will you calculate average annual cash inflows? So the formula is total cash inflows divided by life of the project. So suppose this year you're getting 50,000, next year you're getting 1 lakh, after that you are getting 75,000. So take the total of all the inflows. So 50,000 plus 1 lakh plus 75,000. Take the total of 3. Suppose if the life of the project is 3 years. So you get 2,25,000 divided by 3. You will get the average annual cash inflows. Put it here. Average annual cash inflows. You get the PV factor. Now you know, once you get the PV factor, you know how to calculate IRR. Then use annuity table to obtain the IRR. So you'll get the first trial rate, means the base from where to start. Correct? So again, I'm repeating, whenever the cash flows are unequal, you have to use trial and error method. So for trial and error method, at least you need to know what is going to be the first rate. So for that, you are going to use PV factor. You're going to first find out the PV factor by using initial investment divided by average annual cash inflows. How are you going to calculate average annual cash inflows? Since the cash inflows are unequal, take whatever is the total cash inflows divided by life of the project. Life of the project is means the estimated life of the project. That is how many years the project is estimated to be carried out. Then once you know the PV factor, then you'll already know how to obtain the IRR. See the life of the project. Suppose if the number of years is 5, corresponding to that, what is the PV factor? Corresponding to that, what is going to be your IRR? So that will be your rate of return. Now, application of second trial rate. See students, I have already told you all that IRR means it is going to be that rate where your NPV is going to be 0. Okay, suppose you get the first trial rate as 10%. For example, you get the first trial rate as 10%. And at 10%, your NPV is not coming as 0. See, NPV formula is PV of cash inflows minus PV of cash outflows. Suppose at 10% also you are not getting the NPV as 0, then what you have to do? Application of second trial rate. Means this first rate is not giving you the exact answer, because you have to make sure that by applying that rate your NPV should be 0. So suppose if your first rate is 10%, okay, so your NPV is not coming as 0, then you're going to apply the second trial rate. Remember students, in the first trial rate only, if your NPV is coming 0, then you need not apply the second trial rate. Okay, but suppose if it is not coming 0, then you have to apply the second trial rate. Now on what basis you will apply second trial rate? Suppose if the first rate you got it as 10%, what will you take your next rate to be? So if NPV is positive, suppose based on the first trial rate, that is 10%, you got the NPV as positive, then apply higher discount rate. Suppose at 10% if you're getting positive, then keep applying higher discount rate. At 11% you will solve it and see. Again, if you're getting NPV as positive, then at 12% you will try and see. 15% you will try and see. So apply higher discount rate if NPV continues to be positive. The discount rate is again increased. So what you have to do, it is a trial and error method, students. You have to keep solving it multiple times to make sure that you get NPV as 0. Okay, so at 10% you tried, you got it as positive. At 12% you tried, you got it as positive. So if you want to make it 0, you have to keep increasing your rate, that is discount rate, you have to keep on increasing. Then you try it at 15%, you get it as 0. You get it as positive. So keep trying in higher rates till you get your NPV as 0. So this process is continued till NPV becomes 0, because this method is called as trial and error method. You will try a particular rate. If there is error, then you will try the next rate. If there is error, you will keep trying the next rate. So if it is positive, remember students, if the first trial rate you are applying and if the answer is positive, keep applying higher rates till you get NPV as 0. Now suppose if this answer what you are getting is negative, it comes in negative, but you want 0, it is coming in negative. Then IRR is lying between the positive figure and negative figure, just preceding it. So again, if you're getting it negative, means you know somewhere between 10, suppose if you get the IRR as 8%, at 8% you're getting it negative, at 10% you're getting it positive, means you know 0 will lie between somewhere between 8% and 10%. Means IRR will lie between 8% and 10%, where your NPV will be 0. So if NPV becomes negative, IRR lies between the negative figure and positive figure, just preceding it. Then you have to keep on using the particular formula. This formula you have to use, because if it is between two, if your PV factor is falling between two factors, then you have to use this particular formula and you will get your answer. Keep on trying. It is a trial and error method, so you have to keep on trying till you derive at such rate of return which makes your NPV as 0. That will be your IRR. So again, I'm repeating, when the cash flows are unequal, you're going to use trial and error method. In trial and error method, how are you going to use the first rate? By initial investment divided by average annual cash inflows. How are you going to get average annual cash inflows? That is total cash inflows divided by life of the project. Then you're going to use your annuity table to obtain the IRR. Suppose here you're getting the IRR NPV as 0 at this IRR, then that will be the final answer. Suppose if you're getting the answer as positive, NPV as positive, keep increasing the rate. If you're getting NPV as negative, it is going to be somewhere between the positive and the negative figure. Is this clear? In short, you have to derive at such an IRR which after using it your NPV should come as 0. And NPV, you know how to calculate, PV of cash inflows minus PV of cash outflows. How do you calculate PV of cash inflows? You will use this rate, okay, and bring down all your future values up to the present value. That is going to be your PV of cash inflows. Suppose inflows minus outflows answer is 0, then at what rate it has become 0, that will be your IRR. Is this clear, students? Yes? Yes, students? Is the calculation of IRR for equal cash, for annual cash inflows which are unequal, is it clear? Yes? Yes, students? Is it clear
Yes,
to
ma'am.
everyone? Okay. Again, I'm repeating, you will better understand this when you solve the problem on this, then you will actually understand how it works. Next, moving ahead to the next technique is modified internal rate of return. Now, what is modified internal rate of return? We have seen internal rate of return. Now, what is this modified internal rate of return? See, many financial managers found certain defects in the internal rate of return. So they came up with a new technique, that is modified internal rate of return. Now, this method is also called as return on investment. So saying it works as internal rate of return but with certain modification. So it is nothing but assuming a particular return on the reinvestments of cash flows. So if the cash flows are reinvested, okay, what is going to be the rate of return? It is going to be the modified internal rate of return. It is same as internal rate of return with certain modifications. So MIRR was introduced because they found certain deficiencies in internal rate of return. With that reason, they have introduced a technique that is modified internal rate of return. It is same nothing as return on your investment. Now, how do we calculate the MIRR? It has simple 3 steps, students. No headache. Only 3 steps and you will get the answer. So, first step is you have to calculate PV of the cost. Cost is nothing but the cash outflow. Okay. Present value of cash outflow, everyone knows how to calculate it. We have seen several times in our previous lectures. Next, step 2 is calculate future value of cash inflows. First, what you have to calculate is present value of cash outflow. Then you have to calculate the future value of cash inflow. Okay. Third thing is you have to equate this two. Students, I will just ask you all one question. Can present value be compared to with future value, or are they comparable? Is present value comparable with future value, or present value should be compared with present value itself? Can you all tell me, are they comparable? Is present value comparable with future value? Can you compare those two? Yes? Yes, students? Okay, simple, I'll ask you. Can you compare a 10th standard student with a first standard student?
No, ma'am.
Yes. No. So either you have to compare a 10th standard student with the 10th standard student or first standard student with the first standard student. So similarly, present value you cannot compare with the future value. You have to bring this future value to the present value to make it comparable. If you want to compare, you have to bring the both the values in the same value. So see, you have in the third step you have to equate it. Equate means present value of cash outflow should be equal to your present value of future value of cash inflows. See students, step number 1 is you calculate the present value of the cash outflow. Second step is calculate the future value of cash inflows, and the third step is just equate this two. Now if I have to equate this two, what will be the equation? Present value of cash outflow will be equal to present value of future value of cash inflows, because if I have to equate, if I have to compare, I have to bring both to the same uh, technique to compare it. So present value can be compared with the present value. Okay, now how are you going to find out the present value of future value of cash inflows? Students, we have seen a formula, right? A is equals to P in the bracket 1 plus R raised to N. Do you remember this formula? Where A was your future value? Yes? Students, do you remember this formula? A is equals to P in the bracket 1 plus R raised to N. Yes? Yes, students?
Yes, ma'am.
Okay. Now, if in this equation, if I have to find out the P is the present value. Can you all tell me what will be the formula? Now, same A is equals to P in the bracket 1 plus R raised to N, where A is your future value, P is your present value. Now, if I have to find out P in this, what is going to be the formula? Are you all understanding my question? A is equals to P in the bracket 1 plus R raised to N, where A is to calculate your future value. Now, in the same formula, if I know A, if I know the future value, if I know 1 plus R raised to N, I want to find out P, that is present value. How will I find out? What is the formula? Yes?
P is equals to A divided by 1 plus R raised to N, ma'am.
Very good. So, see here in step 3. Present value of cash outflow, which we already will know in step 1, we will already calculate in step 1, is equal to present value of future value of cash inflow. So as that student rightly said, it is going to be A divided by 1 plus R raised to N. So A is nothing but your future value divided by 1 plus R. MIRR is nothing but the rate of return raised to N. Okay, because we have to find out the present value of the future value. So present value, how do we calculate present value? As one student rightly said, it is A divided by 1 plus R raised to N. So equate this to. So in short, if we use the step number for present value of cash inflow, you are going to use the step number 1. Okay. For future value of cash inflows, you're going to use step number 2 divided by 1 plus R raised to N. So in these 3 simple steps, you will calculate FIRR, students. So again, I'm repeating step number 1, calculate PV of cost. Step number 2, calculate future value of cash inflows. Step number 3, equate this two. To make this comparable, you have to bring this future value to the present value. How to find out the present value? Formula you all know, that is future value divided by 1 plus R raised to N, and PV of cash inflows, which outflows, which you have already calculated in step number 1, future value of cash inflows, which you have already calculated in step number 2, divided by 1 plus R raised to N. So with this, you will calculate the MIRR. Now, what is the decision rule? Suppose again it applies same in case of internal rate of return. Suppose if your rate of return is more than the cost, you're going to accept the investment proposal. If it is less than the cost, you're going to reject the investment proposal. If it is equal to cost, you're going to be indifferent. Is this particular technique clear to everyone? And the steps? Yes, students? Again, I'm repeating, you will better understand it when we solve the problems. Like how this solution exactly goes. Okay, for now, have you all understood? Yes, students?
Yes, ma'am.
Okay. Next. So we were remaining with two techniques, that is internal rate of return, modified internal rate of return, which we have already seen. Now in this particular module, you will have case study, but case study will be on replacement of capital projects. Now this particular case study can come from this module or from any other module, but in case if a case study on this module comes, it will be on replacement of capital projects. Now, how do you decide about replacement? So let me first read this. A replacement decision occurs when an asset is proposed to be replaced with another. See, replacement decision means what? Suppose when asset is become old. So you have to take a decision whether should I continue with that old asset or should I purchase a new asset? Should I replace the old asset? Means obviously when you're replacing the old asset means you want to purchase a new asset. So how to make this decision, students? So this is a replacement decision. Okay, that is called replacement of capital project. How to make this decision, we will see now. So for example, an existing machine is proposed to be replaced in order to enhance production. But whether should the company replace it or should it continue with the old machine? How to make this decision on replacement? So there is an important assumption for replacement, that is the economic life of the new asset is equal to the remaining economic life of the existing asset being replaced. So I'll just explain this sentence with the help of an example. Suppose you have a machinery, okay, old machinery, which is having a remaining life of suppose 4 years. Okay, now it's become old. So you're planning to replace it with a new machinery which is going to have an economic life of 4 years. So this old machinery is having a remaining life of 4 years. In when you're going to make a replacement decision. So this is an important assumption. What is the important assumption? The economic life of the new asset is equal to the remaining economic life of the existing asset being replaced. Suppose the old asset had a total life of suppose 10 years, out of which after 6 years you're deciding to replace it. So the remaining old asset, you have to just see the remaining life. Remaining life is 4 years. New asset economic life is 4 years. This should be equal when you're making the replacement decision. So this is an important assumption. Now, how you are going to make a decision rule? Decision means, again I'm telling you, whether you should go in for the replacement or whether you should continue with the old machinery. How are you going to make a decision? There are two techniques. One is NPV technique and one is IRR technique. You can use any technique whichever you are comfortable. Okay. So in NPV technique, first step, you have to use the required rate of return as discount rate. See students, in the problem of replacement, you will be given a rate of return. That rate of return you have to use as discount rate. Now why discount rate is used? In order to bring PV of cash inflows to the present value, you use a discount factor, right? So first, use whatever rate of return is given in the problem, you use it as a discount rate. Second, calculate NPV of incremental net investments and incremental cash inflows. See students, how do you calculate NPV? PV of cash inflows minus PV of cash outflows, but only the increased incremental. Now when I say incremental means, suppose if you're going in for a new machine, so what is the excess cash inflow you will be getting and what is the excess? Incremental means over and above, not the normal cash inflows and outflows. Over and above, what is the inflow you will be getting if you're replacing it, and what will be the increased cost that you have to bear to replace it. So you have to calculate NPV only of that increased inflow and outflow. Third step, accept the proposal if NPV is positive. Means you can replace the asset and purchase the new asset if the answer of NPV you're getting is as positive. But if NPV is coming negative, you do not replace the asset. Continue with the old asset only. So again, I'm repeating, replacement of capital project NPV technique. If you're using, first, whatever rate is given in the problem, you use it as a discount rate. Second, you calculate NPV, but NPV you are going to calculate not of the normal cash inflows and outflows, of the incremental, means over and above whatever you're getting the increased cost or increased cash inflow. If NPV is coming positive, you go in for the replacement, purchase the new asset, discard the old asset. If NPV is coming negative, do not purchase, do not go for replacement, continue with the old asset only. This is NPV technique. IRR technique means, first compute the IRR of incremental cash flows. Means suppose if you are replacing it, what is the increased cash inflows you will be getting? So compute the IRR. Now how to compute the IRR? You all know. Second step, if IRR is greater than cost, accept the investment proposal. Means if your rate of return is more than the cost, you go in for replacement, discard the old machine, buy the new machine. Now, if the return is less than the cost, then you reject the proposal and continue with the old machinery. Do not go for replacement. So these are the two techniques. Whichever you want to use, you'll use in the exam. NPV technique, IRR technique. Okay. Based on these steps, you will at last come to know whether you have to make the replacement done decision to be in favor or not in favor. Is this clear, students? Yes. Yes?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay. Now we had to see problems on IRR, MIRR and case study, which we will see now in the next lecture, since we have only 5 minutes left and we will not be able to cover all the problems. So thank you so much, students. We are done for the session for